Hey everyone, and welcome. Today, we're about to go on a really cool journey. We're going to go from a simple thought kicking around in our heads all the way to a command that a computer can actually understand and follow. We're going to pull back the curtain on the world of programming and see how an idea becomes real, executable code. So, let's get started. Have you ever really wondered how we talk to machines? How do we take something totally abstract, like an idea, and turn it into something real, like an action on your screen? Well, that's exactly what programming is all about. It's the language we use to solve problems, the ultimate bridge between how we think and how a computer operates. So, where does that journey begin? Well, it all starts with one single super powerful concept, the algorithm. Before you ever write a single line of code, you gotta have a plan. I mean, how do you actually do it? You can't just lean over and say, "Hey, computer, could you add these two numbers for me?" It doesn't work that way. A computer needs super precise instructions, a detailed step-by-step recipe that it can follow without any confusion, and that's the whole challenge that programming solves. And that recipe has a name. It's called an algorithm. And you should really think of it just like that, a clear step-by-step guide for solving one specific problem. It needs a clear beginning, a clear end, and every step has to be logical. And trust me, these recipes are absolutely everywhere, running everything from your social media feed to the GPS that gets you home. Okay, let's make this super concrete. Here's a very simple algorithm for adding two numbers together. Just look at how every single step is a small, crystal clear action. First, we start. Then we get our first number. Then we get our second number. We do the math, putting the result in total. Then we show the result, and finally, we stop. That level of clarity is exactly what a computer needs to get the job done. Okay, so having a list of steps is great. But you know what they say, a picture's worth 1,000 words, right? That's where we take our text-based plan and turn it into a visual map of our logic. And that map is called a flowchart. It is, for all intents and purposes, the blueprint of our algorithm. It lets us actually see the flow of our logic, to trace the path our instructions are going to take from the very beginning to the very end. Now, flowcharts use a standard set of symbols. It's like their own little language. The oval shape, that's your starting and finishing line. Rectangles are for processes. These are the action steps, where the work actually gets done. The diamond shape is for when you need to make a decision, a fork in the road. And of course, you have arrows that connect everything, showing you which way the process is flowing. All right, let's put it all together and turn our little summing algorithm into a flowchart. It would start with an oval for start, then an arrow to a rectangle for get numbers, then another arrow to another rectangle for add them, an arrow to one more for print result, and finally an arrow to an oval for end. It's a simple, brilliant way to map everything out visually before we even think about touching a keyboard. Okay, so we've got our plan, the algorithm, and we've got our visual blueprint, the flowchart. So what's next? Well, now we need the actual tool, the language, to communicate this plan to the computer. And for that, let's say hello to a real classic, a powerful language called C. So a little backstory on C. It was born way back in 1972 at Bell Labs, and it was originally built for a very specific purpose, to create the Unix operating system. It's known as a middle-level language, which is really cool because it means you get the best of both worlds. It's readable like a lot of modern languages, but it also gives you the low-level power to get really close to the computer's hardware. And here it is, the rite of passage for every single programmer. This is pretty much the first thing anyone learns to write. It's our first real conversation with the computer, a simple but powerful instruction that just tells the machine, hey, display the words "Hello World" on the screen. But wait, how does that text actually do something? It's a three-step process. First, we write our instructions in a file. That's called our source code. Second, we use a special program called a compiler to translate our C code into the only language the computer truly understands, machine language. And third, we run that newly created executable file. It's always write, compile, and run. All right, so that block of code might look a little intimidating at first, but it's not just a bunch of random symbols. It has a very specific structure and anatomy. So let's put it on the operating table and dissect our Hello World program piece by piece. Okay, here's our Hello World program again. We're going to zoom in on this and break it down line by line so you can see that every single symbol, every word here has a very specific job to do. Let's start at the top. This first line, #include stdio.h, is kind of like telling your program, hey, before we start, go grab my standard input/output toolbox.
This toolbox, or library, is full of pre-made tools, functions like printf that let us do things like print text to the screen. It means we don't have to build that tool from scratch. We just include the library that already has it.
Next up is the main function. Every single C program has to have one of these. It's mandatory. Think of it like the front door to your house. When you tell the computer to run your program, it immediately looks for this exact door, main function, to get started. All the action begins here.
Inside that function, we have what are called statements. These are the individual commands, the actual things we want the computer to do. In our program, printf, hello world exclamation, is one statement. And you see that semicolon at the end? That's basically the period at the end of a sentence. It tells the computer, okay, this command is finished. Move on to the next one.
And what about that line that starts with the 2 slashes? That, my friends, is a comment. It's basically a sticky note you leave for yourself or for other programmers who might read your code later. The compiler, the program that translates our code, completely ignores it. It's 100% for us humans.
So there you have it. We've gone all the way from a simple idea to a structured algorithm, we mapped it out with a flowchart, and we finally brought it to life with actual code. We've unlocked the fundamental process of how to talk to a computer. See? Programming isn't some kind of magic. It's just a really powerful tool for creating things. The only real question left is, what problem will you solve next?